Hey everyone. So in this lesson, we are going to talk about reviewing solving equations, but I also want to talk about the idea of note-taking for my class because this is our first actual lesson, even though it's a review lesson on solving. I want to make sure that we're good with how to take notes. So a couple things. You don't have to write down this screen. I'm going to model what note-taking looks like through my notebook here so you can see. But a couple notes on note-taking. It should be in a spiral-bound notebook. So, like I said in a previous video, college-bound, spiral-bound notebook, okay? You are going to reserve the right hand of each page for notes and examples. So you're actually going to skip page 1. Okay, let me see if I can bring this up here. Because page 1 doesn't have a left-hand side, right? You have a blank cardboard piece and then the paper over here. Well, we're going to turn that page so that we are actually on another page, okay? Something like this. In fact, I'm going to turn another page, okay? So turn 2 pages in. Then that's where you're going to begin your notes. Now, on the right-hand side over here, you're going to take any notes, examples, definitions, things like that. And then we'll talk about the left-hand side in a second. On the right-hand side, you're going to use modified Cornell-style notes. Well, what does that mean? Maybe you've never been introduced to the idea of Cornell notes. That's okay. We're going to talk about it right now. Basically, what I'm looking for in terms of a Cornell-style note is the title. I am looking for the essential question, and normally that's written as an objective, and you write it as a question. You rewrite it so it says a question, okay? And then the body of notes, so the main purpose of the notes, and then at the end, a summary, and the purpose of the summary is to answer the essential question. So that's the format, okay? You're going to write down the title, the essential question, the body of notes, and the summary. And the more and more you do this, the more and more you familiarize yourself with the process. But just make sure you follow along with that. And then on the left-hand side, so over, not here, but on the other side, so pick up the camera, right? On this side, this is going to be reserved for any type of discovery or exploring kind of activity or any kind of practice. So the left-hand side, the content of this left-hand side should match the content of the right-hand side. It should not match the content from the previous page, okay? So this is going to be lesson 0.01. You'll see that in a second. And then this will be the practice for 0.01. I know it seems kind of backwards. Why are we doing the practice after we do the examples? But there's a reason for that. The majority of the stuff we do, the important stuff, is written on the right-hand side so that when you turn the page, that's the first thing you see. And then if you need to see more practice or more examples, you'll see it over here through your work. The other idea is anything that's on the right-hand side is information that I have given you as the teacher. So you can be completely confident that it is accurate and correct. Sometimes I make mistakes, but we'll fix those as we go along. But you can trust that what's over here is what I want you to know. Over here is your opportunity to practice it. So when you're studying for a test, you're going to be studying off this right-hand side because you know it's right. Whereas on the left-hand side, you have maybe made some errors through your exploration. Maybe you came up with a different conclusion than what I was trying to get you to get to. But over here, you know it's right. So this is your study side, essentially. Okay. So with that said, the last part of note-taking is that you are going to keep your notes in this spiral-bound notebook. There should never be a case where you rip the pages out, throw them away, or do anything else with them. They should stay in your notebook. But what you're going to do is you're going to take a picture of each of the pages of your notebook for each set of notes, and you're going to paste those notes into a Google Doc, and then you're going to submit those notes through Google Classroom so I know that you are taking notes correctly, okay? So again, you're going to take a picture of your notes, you're going to paste them onto a Google Doc, and then you're going to submit them into Google Classroom, okay? So please follow along that process when taking notes. So with that said, let's go ahead and get started. Remember, we want We want Cornell style. I don't really care about the line that's drawn through here. If you are an avid student and you find that they require that, then go ahead and do that. But what I want is your title, and the title is going to go in the upper margin. So you're going to write down 0.01, and you're going to say review linear equations. Okay. Review linear equations. Then from here, you're going to write down your essential question. So today, and I'll just put EQ here, EQ, okay? Today, the objective says I can solve a multitude of linear equations. What we want to do is we want to write that as a question. How can I solve a linear equation? Okay, you never want to change it or make it say, can I? Don't just flip the words I can to can I. That's a yes or no question, and that's not an acceptable type of summary because a summary requires sentences, not a single word. So how can I? How do you? Something along that line. So how do I maybe solve a linear equation? Okay, so now I have my title, my essential question. What I'm going to do now is draw a line, and I'm kind of particular, so we're going to draw a line at one line here, okay? And normally you would draw your vertical line here for your Cornell style notes. Again, for this class, I'm not too concerned about that. That depends on any other teachers that you might have. But now we're going to get into the body of notes, okay? So this is notes. This isn't a practice problem or anything else, so you need to write it down. So you're going to write down expression. What is an expression? Well, okay, now I'm not going to do this letter for letter. You're going to write down that definition. I've already written this down over here. I don't want to do it again. So you're going to write down what the definition of an expression is, okay? An expression is numbers and letters and operators grouped together that represent a value. Well, an operator is like adding, subtracting, dividing, squaring, you know, something like that, an exponent, parentheses. These are all operators. Numbers and letters are mixed together in these things, and ultimately this represents some sort of value, whatever it might be. It might be the cost of your electric bill or your cell phone bill. It might be how many bags of dirt you need to fill up a bucket. There might be a whole multitude of interpretations or meanings behind these expressions, but that's all an expression is. And so notice that an expression does not have an equal sign to it. It just represents a value. And so an example of an expression is something along the order of 5. That's an expression. That is a number or a letter or an operator or any combination of those. So that's an expression. 3x is an expression. Why is 3x an expression? Well, 3x represents or means 3 times x. So here's your number, here's your letter, and your operator is implied by multiplication. Because there is no operator, we say it's multiplication. Another example of an expression is 2xy minus 11. You have letters and numbers and an operator in there and multiplication, subtraction, so that's an expression. Another one is something that maybe looks completely gross, right? This is something that you might see in Math 3 in the future, okay? So again, letters, numbers, operators, these all represent expressions. So in your notes, I want you to focus on the content too, but going back to that, talking about notes, you've written down expression, you've written down the examples of those expressions. Now we're going to move on to equation. And what does an equation mean? Forgive me, my notes are very blurry here. But what is an equation? Well, an equation is a statement that shows two expressions are equal to each other. Okay, an equation is two expressions with an equal sign in between. So it has an equal sign, whereas an expression does not have an equal sign. So examples of this might be 3x plus 7 equals 19. What are we doing? We're making one expression equal to another expression. So whatever value we have over here is the same as whatever value we have over here. And ultimately, when we go to solve, the idea is to figure out what x value would be plugged in here so that this left-hand side is the same as the right-hand side. Another example of an equation is 3x squared plus 7 equals 19. Now notice the operators here. In the first one, we have multiplication, and we have an addition for this expression. In this one, we have multiplication, we have addition, and we also have an exponent there. That's another example of an expression. Now, in previous courses, in Math 1 specifically, you learned that this first one is called a linear equation, and that it only has one solution to it. This second equation is called a quadratic equation, okay? It can have up to 2 solutions. Now we're going to get in, our main focus actually in Math 2 is to explore the quadratic equation, okay? The quadratic function, if you would, and how to solve that, how to graph it, how to do a bunch of things with it. But that's not the point right now. I just wanted to point out it's quadratic. So you got your notes for your equation, you got your examples here, you've written all that down. Another side note here is that the highest power of the exponent is 1 for a linear equation. See how the exponent here, there you don't see an exponent. Well, it's implied that it's a 1 because something like 4 raised to the first power is 4. 5 raised to the first power is 5. You don't have to put the exponent when you mean 1 because it doesn't change the value. But if you notice in the second equation, the quadratic equation, that the highest power is 2. You see the exponent is 2. That's what makes it a quadratic equation. All right, enough of that. Let's go on to solving equations. Now we're going to be talking about solving equations. So I'm going to write that down, solving equations. And what is the purpose of solving equations? Well, the goal, and we're writing this down, the goal is to isolate the unknown variable in order to determine its value. So when I had that equation that was something along the order of like 3x plus 7 equals, I don't know, 21, right? 3x plus 7 equals 21. That is an equation that can be solved. Our goal is to isolate, to get alone the variable so that we can know what its value is. Okay, so that's what our purpose is in solving an equation. Again, you're writing that down. You're writing this down in your notes. And now we have an example. So we're going to write down the example here. Example. Okay, example or examples. Okay, and we're going to write this down letter for letter. Number 1 says -7 plus x equals 13. And so now we're going to get to actually doing some math here. -7 plus x equals 13. It's an example, so it's going on the right-hand side. Well, what do we do to get x by itself? We need to isolate to get alone the x thing. So what do we have here? Well, we have a -7. I'm going to try and focus this here because this doesn't seem like it's focusing. There we go. We have a -7 that we're adding to x. When we go to solve an equation, we're actually doing the opposite of the order of operations. We're undoing the order of operations because normally we have a number here and we're doing the order of operations to figure out what this is equivalent to. But we know what it's equivalent to, so we're working backwards to figure out what this value is. So how do I get x by itself? Well, I have to get rid of this -7. And what is the operator that I'm doing with this -7? Well, I'm adding it to x. So I need to do the opposite, essentially, of addition. So I need to subtract a -7. What? Subtract a -7? What is subtracting? Sorry, my hand's getting in the way there. What does subtract a -7 mean? Well, it actually just means add a 7. Subtracting a negative is the same as adding. So we're just going to add 7 to both sides. Whatever you do to one side, you have to do to the other. And so we end up with, on this side, these cancel out, and you're left with x equals 20. We can check our work by plugging that in. -7 plus 20 is 13. Okay. For number 2, I'm going to write down my example. 5x equals 35. Well, what's the operator here that gets x by itself? Or what's the operator that I'm doing with the 5 and the x? I'm multiplying. So how do I get rid of multiplication? Well, I'm going to divide. Well, I'm going to divide by 5 because I was multiplying by 5. So to get rid of that, I'm going to divide by 5. As a result, I end up with these being reduced, and I'm left with x equals 7 as a final answer there. And then for number 3, we've got x over 4 equals -2. Well, what's the operator going on here? This tends to confuse students because they see, oh, it's a fraction. I don't like fractions. Guys, fractions just mean division. Fractions mean division. So what are we doing? We're dividing by 4 here. How do I get rid of it? I multiply by 4. So I'm going to multiply both sides by 4. Well, this side's easy. -2 times 4, that is -8. On the other side, what happens there? Well, the reason we were multiplying by 4 is to cancel out or to eliminate or reduce the dividing by 4. The way you can think about it if you need to is that this is 4 over 1. And so when we go to multiply these, we can multiply them straight across. And so we'd actually end up with 4x, 4 times x is 4x, and then 1 times 4 on the bottom is 4. But you can see that the 4's reduce. Either way, the top 4 and the bottom 4 reduce, and you're left with x over 1 or just x. And so there is your answer there. And you can check it again. Check your work. Plug in -8. -8 divided by 4 is -2, and you have your answer. So those are my examples. The reason that they are written on the right-hand side is because that is the correct way of doing it. I am now going to provide, it looks like I've got the answers here, I'm going to provide practice problems for you. Because these are practice problems, you're going to put them on the left-hand side. So we're going to come over here and we're going to put our work on the left-hand side. And so we're going to say, okay, this is practice. And then number 4 is x plus 12 equals 18. Number 5 is -4x equals 36. And number 6 is x over -3 equals -11. Now, this is your opportunity to pause the video. You try solving these on your own, and when you're done solving them and you think you have an answer, come back and watch the video to see the correct way of doing it. Okay, so you should have paused the video. I hope you did. You didn't just keep playing. And now we're going to go over these problems to see if you did it right. I've got x plus 12 equals 18. How do I get rid of the plus 12? Well, I'm going to subtract 12 from both sides. Remember, whatever you do one side, you got to do the other. So here, those reduce. You're left with x equals 6 as your final answer. For number 5, that says -4x equals 36. The operator here is multiplication. So I'm going to divide to get rid of the multiplication. We're going to divide by -4. Well, -4x over -4 simplifies to x, and 36 over -4 simplifies to -9. And that is our final answer there. And then the last one is very similar to the one I gave you. How do I get rid of this -3? Well, I'm going to multiply by -3 on both sides. Okay, so we end up with, these reduce, we're left with x equals, and -11 times -3 is +33. Now, these are called one-step equations. Why are they called one-step equations? Because it only took one thing to do, one step, in order to get x by itself. Let's go ahead and go back to our notes here. Okay, we've got our notes, our examples. We're going to go on to multi-step equations. And so we are going to go in our notes and we're going to write down multi-step equations. Well, what does that mean? That means it's going to take more than one step to solve them. A multiple step equation, again, you're going to write this down. Take your notes, okay? A multi-step equation is an equation where more than one operator is needed to solve, okay? So you may need to distribute or combine like terms as a part of this and remove variables on one side of the equation. I don't like saying move them over to the other side, but remove them from one side, and whatever you did to that side to remove them, you're going to do the same thing to the other side. Okay, you may need to do that, and you should be writing these down as notes. So you got all that down, and now we have another set of examples. Well, let's take a look at what those examples are. Number 7 is 4x plus 6 minus 2x plus 5 equals 17. Now, this one looks a little bit more complicated than the previous problems, but believe me, it's not horrible. Okay, I'm going to give you kind of a routine here. The first thing you want to do, so this is all on your right-hand side because it's an example. The first thing you want to do is try to distribute and try to combine like terms. Well, there's no distributing going on here because there's no parentheses. So the next thing we're going to do is we're going to combine like terms. So we don't want to move things from one side to the other. We don't want to cancel those things out. What we want to do is just anything on the left-hand side, we're going to try and put together. Well, the 4x and the negative 2x are like terms. They go together. So 4x and negative 2x is 2x. And then the 6, the positive 6 and the positive 5 are like terms because those are constants. There's no value, there's no variables there, so you can just combine them. 6 plus 5 is 11, and then that's equal to 17 on the other side. So from here, now we're down to a lot simpler equation, but now we have two operators here. We have multiplication and we have addition. We need to get rid of both of them. And when we go to solve an equation, remember we do order of operations backwards. So normally we would do multiplication first and then addition, but here we're going to do the opposite to get rid of things. So how do I get rid of addition? I subtract. And so I'm going to subtract 11 from both sides. I end up with 2x equals 6. And then how do I get rid of the 2? Well, that's multiplication, so I'm going to divide. Oops, not divide by 3, divide by 2. And so we have our answer of x equals 3. Okay, and there we have it. Okay, now number 8, let's go ahead and take a look at what number 8 looks like. Giving you a slew of different ways or different examples that you could see. We have negative 2x times 4x minus 3 equals 14. Well, here again, the first thing we do is try and distribute, and then we try and combine like terms. So here we have parentheses, so we're going to distribute. What is negative 2 times 4x? Well, that's negative 8x. What is negative 2 times negative 3? Well, that's positive 6 equals 14. And now we're down to what we have here, basically a two-step equation. I want to get rid of multiplication and addition. So the first thing I'm going to do is get rid of the addition by subtracting 6. And so we end up with negative 8x equals 8, because 14 minus 6 is 8. And the next thing we're going to do is divide by negative 8. And we end up with x equals negative 1. Okay. And then we have one more example here. The last example, number 9, is 5x plus 11 equals 8x minus 1. Okay, now this one's a little bit different because what we notice is that there's variables on both sides of the equation. So the first thing we're going to try and do is distribute and combine like terms. But remember, you're only distributing and combining like terms within an expression. You're only distributing and combining like terms on one side of the equation. So looking at this side of the equation, can I combine anything over here? No. Anything, and then now we look on the right-hand side. Is there anything I can combine? No. So we've done our combining like terms in a distribution. There was nothing to do. The next step is to get all the variables on one side and all the constants on the other. So what we're going to do is either move this over here in a sense, and again, I don't like saying move even though I keep saying it. We want to get rid of this x over here or get rid of this x over here. Now, to keep it simple, I'm going to make it so that all the x's are on the left-hand side and all the constants are on the right-hand side. So what do I have to do to get rid of this 8x here? Well, this is a positive 8x, so I'm going to subtract 8x from both sides. Okay? Now, when I do that, 5x minus 8x is negative 3x. And then this 11 still stays there. We haven't done anything with it. The 8x minus 8x, those cancel out. 8x minus 8x is 0. And then we're left with the negative 1. Okay? From here, we're going to get rid of this addition just like we did on the previous problem. So we're going to subtract 11 on both sides. And so we end up with negative 3x equals negative 12. And then we're going to divide by negative 3. And then we end up with x equals 4. Just a side note, if your notes are getting crowded, don't try and cram them in the end. Feel free to go ahead and turn the page and continue on, but make sure when you continue on the notes or the examples, it's on the right-hand side and the practice is on the left. We're going to start a fresh sheet of paper every day we do notes, but you can continue on to multiple pages if you need to. Okay, so those are my examples for solving multi-step equations. And now we're going to go into some practice. So again, you're going to put this practice on the left-hand side of your notebook. and you're going to pause the video and you're going to do these on your own and then come back and watch the video to see how you did. All right, did you finish solving them on your own? Well, in this case, let's go ahead and go over it and see how you did. In this case, we have no distribution, but we do have combining like terms. We have this negative 6x, this negative 3x, and this 4x. Well, negative 6x minus 3x is negative 9x, plus 4x is negative 5x. Okay, and then we have the negative 7 and the 12, positive 12. That turns into plus, what is that, plus 5? Do I have this right? Yes. Plus 5, and then equals 9. Nothing to do on the other side. We're going to subtract 5 from both sides. And so we end up with negative 5x equals 4. And then we will go ahead and divide by negative 5. And here we actually get a fraction as an answer. That's okay. Fractions are okay. So we end up with negative 4/5. Now, if you put that in decimal form, if you used a calculator, you should have got negative 0.8. Either one of those answers work, or negative 0.8. Those are equivalent. Okay. Now let's go ahead and take a look at number 11. Number 11 says 6 times x plus 4 equals 12. And to backtrack a little bit, if you're stuck on anything on these notes or these practice problems or whatnot, what you should be doing is putting a star next to the place where you're having a hard time. Maybe make a note in this column. That's why Cornell notes are kind of nice. Make a note over here saying what your question is or where you're struggling. So that way when we're live, you can ask me for that help. Okay. All right. Number 11, the first thing we're going to do is we're going to distribute. So we end up with 6 times x is 6x, 6 times 4 is 24, and that's equal to 12. From there, we're going to subtract 24 from both sides. And so we end up with 6x equals negative 12. And then we'll divide by 6, and we end up with x equals negative 2. And that is that practice problem, okay? And the last problem here on this slide is negative 4x plus 7 equals 5x minus 29. Remember, our goal is to get the variables so that there's only variables on one side and a constant on the other. So the first thing I'm going to do is get rid of this 5x by subtracting 5x on both sides. And then, excuse me, and then I end up with negative 9x plus 7 equals negative 29. And then we're going to subtract 7 from both sides because the opposite operation of adding 7 is subtracting 7. So we end up with negative 9x equals negative 36. And then we'll divide by negative 9. And we end up with x equals 4. If you are not getting these problems correct, and you're looking at my work and going, okay, I kind of get it now, you should be writing my work down so that you have something else to reference that's correct. It's always a bad idea to reference notes that are not correct. So if you're doing a practice problem and you did it wrong, cross it out and then do the right way next to it. All right, we are almost done here. We got one more slide to go. We've got 2 more examples to look at. I'm going to go ahead and turn my page over to the other side, and because they say examples, we're going to put this on the right-hand side of our notes, and I'm going to go ahead and make this bigger now, or at least a little bit bigger. Number 13, if you think that you can do this on your own, go ahead and pause the video and do it, and then come back and see how you did. If you need help, then let's walk through this first one together, and then you can do the second one on your own to see how you did. All right, first thing we have to do is distribute and combine like terms. Well, on the left-hand side, whoa, sorry, can't see the problem. On the left-hand side, there's nothing to combine and there's nothing to distribute. On the right-hand side, there is something to do. We have to distribute. So we end up with 5x plus 34 equals, well, negative 2 times 1 is negative 2, and negative 2 times negative 7x is plus 14x. And then from here, we're going to move or make it so all the variables are on one side. So in this case, I got to adding 14x. I'm going to subtract 14x from both sides. And so I end up with, well, 5x minus 14x is negative 9x plus 34 equals negative 2. And then I'm going to go ahead and subtract the 34 from both sides. And I end up with negative 9x equals negative 36. We'll divide by the negative 9. And we end up with x equals positive 4. So hopefully you got that one right. And then number 14, looks like we have something very similar here. 2 times 4x minus 3 minus 8 equals 4 plus 2x. So the first thing we're going to do is combine like terms and distribute. On the left-hand side, do we have any distribution to do? Yes, we do. So let's go ahead and do that. 2 times 4x is 8x. 2 times negative 3 is negative 6. Notice we don't distribute to the negative 8 because that's not in the parentheses. The next step is, do we have any combining like terms to do? Well, looking at the left-hand side, there is some combining that we have to do. The negative 6 and the negative 8 go together. So we're going to combine those. That's 8x minus 14 equals, and then we could ask the same question on the right side. Is there any distribution or combining like terms? No, there's not. So we're just going to carry that down. If we had distribution over here, just like we did over here, we could do that all in one shot, all in one line, distribute over here and distribute over here, but we don't have that. All right, we're going to move or get all the x's on the left, so we're going to subtract 2x from both sides. And so we end up with 6x minus 14 equals 4. And then we'll add 14 to both sides. And we end up with 6x equals 18. Then we'll divide by 6. And we end up with x equals 3. All right, so that actually wraps up. Oh, there's more practice. I'm sorry, I lied. Those are examples, okay? Now we have more practice problems to do. So these are yours to do on your own, okay? So go ahead and write those down on the practice side and pause the video and see if you can do them, and then come back and watch the video to see how you did. Okay, for number 15, I'm going to kind of go fast through this. We're going to distribute, and notice we got two forms of distribution here. We got the first negative 3, that becomes negative 12x minus 9, and then the next one becomes plus 24x plus 4, and that's equal to 43. Sorry, my hand's getting in the way there. The next thing we're going to do is combine like terms. So we got a negative 12x and a 24x, so that will be 12x. And then the negative 9 and the 4, that turns into negative 5, and that's equal to 43. Now to get rid of the negative 5, we're going to add 5 to both sides, and we end up with 12x equals 48. Then we will divide by 12 and get x equals 4 for our answer there. Number 16, we got a lot of distribution here. Negative 5 times 1 minus 5x. Hopefully you've done this problem already on your own. Okay, we're going to go ahead and distribute and combine like terms as we can. On the left-hand side, we have to distribute twice. And so we end up with negative 5 plus 25x minus 40x minus 10. Now notice on the right-hand side, we actually have something to do. We have to combine like terms there. If you want to hold off on combining like terms, you can. That way you're all doing it in one step. That would make sense. Distribute and then combine like terms. Because on the left-hand side, we have to combine these guys. Notice I'm not combining all 4 together because this equal sign is here. We're only working on one side at a time. So positive 25x minus 40x is negative 15x. And then we have negative 5 and negative 10, which is negative 15. And that's equal to negative 4x minus 8x. Oops. I need to combine like terms there. So now we have this set of like terms. The negative 4x minus 8x is negative 12x. Now, this one, maybe you did this according to the pattern that I've been giving you, but you can move the x's. You can have the x's on either side. You could have them on the left or the right. You see, if I move them, if I have them all on the left, I would add 12x to both sides, and I'd be left with 0 over here. Then I would have to move the 15, add 15 to both sides, and so on. But if I add 15x to both sides, what's that going to do? That's going to cancel this guy out. And then you're left with negative 15 equals 3x. And then we'll divide by 3. and you're left with -5 equals x. Well, that's the same as saying x equals -5, and that is your final answer. All right, now with that said, that is the end of the notes. So the last thing you need to do, remember, in your notebook is to write your summary. So you're going to take your ruler, and at the end of your notes, you're going to draw a line just like you did at the beginning. Draw your line, and then you're going to write your summary. Now remember, writing your summary, the purpose of writing the summary is to answer the essential question. So I'm going to go back to the previous page and look at my essential question. The essential question says, how do I solve linear equations? Well, how do we solve linear equations? What did we learn? How do I solve linear equations? Well, first step, the first thing, let me get this straight here. The first thing is to distribute and combine like terms. Okay, that's the first step. The second thing we need to do is then, however you want to say this is your summary for you. Then we try to isolate the variable. Then we isolate the variable, and we do that by getting all the x's on one side and the constants on the other. Okay, and that's essentially the answer, right? There's a few things that you might have to do, idiosyncrasies, if you would, for that last sentence, but that's the main idea. And that's your notes. So now you'll take a picture of your notes. Now, in my case, I've got 4 pages. I got page 1. I got 2 pages actually that I'm going to submit. I got 2 pages, page 1 and page 2 here. So you're going to take pictures of the right-hand side. You're going to paste them to a Google Doc, and you're going to post them to the assignment in Google Classroom. The other thing I want to talk about is notes in your notebook. I'm going to go ahead and label pages here. Okay, so up in the upper right-hand corner, we're going to call this page 1. Okay, and this is page 2. Okay, we don't have to worry about the practice side, page 1 and page 2. And so now we can actually go to our very first page of our notebook, right at the very beginning, and we can start creating a table of contents that, if you think this is beneficial, but we're going to create a table of contents. And so we're going to say unit 0. This is unit 0. And the title of this unit is review. Okay, so we would say 0.01. The title of this was review or reviewing linear equations. Okay, and then you would say page, and this was page 1. You could say page 1 through 2 if you'd like. Okay, and then the next lesson will go underneath that, and so on. But anyways, that's that for this. I know it was kind of long-winded, but we were trying to cover 2 things at once. We're trying to cover solving equations, but we're also trying to cover how to take notes. And I'm not going to walk you through those notes like that every single time, but hopefully you found that helpful. And if you have any questions, make sure you are asking for help when you need it. I will talk to you later.